Okay, so we tried starting this on Friday, but we really didn't get through much of it. So let me try to do this one again. Okay, what is the sum of this infinite series? So first of all, is this series arithmetic or geometric? Geometric, because we are multiplying by what every time? 2. All right, so to figure out what is the actual sum, we need to write the explicit formula again. Did you guys write the explicit formula already? Oh, you did? Okay. 3 times 2 to the n minus 1. Okay, again, we need to figure out how many terms there are, right? Sorry, this is page 11. Huh? Oh, okay. All right, so this is the explicit formula for this series. If it were a sequence, 3 times 2 to the n minus 1. Now, what is this? So we want to figure out what n number this is, right? 3072. So we need to make it equal to 3072. It's just like the warm-up. So what should you do next? Divide by 3, okay? Do not multiply 3 and 2 together. Okay, divide by 3. 2 to the n minus 1 is equal to whatever that number is. Now remember that because n is a term number, it will always be an integer, which means the base will always be able to become the same. Okay, you can always change the base to be the same because term number is an integer. Okay, 3072 divided by 3, 1024. Okay, so change 1024 into a base of 2. Okay, so 2 to the n minus 1 is equal to 2 to the 10. So n minus 1 is equal to 10. N is 11. Okay, that's good. Now, this is asking for the sum. So we are not writing a summation notation. We are actually evaluating what the sum is. So I think you wrote this down before. So sum of n numbers is equal to a1 times 1 minus r to the n over 1 minus r. So this is a very long formula to memorize. Don't have time to derive it, but this is the sum of an arithmetic series. So let's go ahead and apply. Sum of 11 numbers is equal to the first number. What is the first number of the series? 3 times 1 minus, what is r? 2. What is n? 11 divided by 1 minus 2. Okay, so now use your calculator to figure out the answer. Now, again, logically ask yourself, what kind of answer should you get? If you add up all the numbers, you should get an integer that is positive. If you end up with a decimal, it's wrong. If you end up with negative, it's wrong. Okay? So use your calculator and figure out the answer. Okay, the answer is 6141. Good? Yeah, so please be careful, especially with, there's a negative on the top and negative on the bottom. So easy to kind of get a negative number instead of positive. Okay, evaluate. So let's go ahead and have you practice this one. Again, find out how many term numbers there are by using the explicit formula. And then because this is a geometric series, you want to use the geometric sum. Okay, so we know that this is a geometric series, so we want to write a geometric formula. So explicit formula, 4 times, this r is 3, so 3 to the n minus 1. And we want to figure out how many terms there are, so that's equal to 972. Very important, do not multiply 4 and 3 together. Divide by 4, so 3 to the n minus 1 is equal to 243. So 3 to the n minus 1 is equal to 3 to the 5th. So n minus 1 is equal to 5, n is equal to 6. Okay, so sum of 6 numbers and use the formula. A1 is 4 times 1 minus 3 to the 6th power over 1 minus 3. So this is equal to 1, 4, 5, 6. Yes?
Can you show how you actually solve the formula?
Yes. Oh, you mean the term number? Or?
Oh, no, the sum of the...
Oh, how to do it. Okay, so you want to do it with order of operations. So what you want to do is this first. So Cam does, right? Parentheses. There is a parentheses. So inside the parentheses, you check again. Is there parentheses? Nope. Second part is exponent. So check the exponent. 3 to the 6 is whatever that number is. 3 to the 6. 729. So then I will write it like this. 4 times 1 minus 729 over 1 minus 3. So I try not to type everything in the calculator because I make mistakes. And then so 1 minus 729 is negative 728. And then divide by negative 2. And then just kind of do it that way.
Okay, thank you.
All right, next one. Find the sum of the finite geometric series. So they're actually really nice. They told you that this is a geometric series. Before you figure out what the sum is, let's just write out a few terms. This is from term what? The sum is from term what? 0 to what? 20. So how many numbers are there? 21. Okay, so be careful with number of terms. Okay, n is the term number. The formula is 4 times 1/2 to the n. First term is term 0. Okay, so be careful. If they want you to start at 0, you have to start at 0. And we're going to just check maybe 4 terms just to see what the pattern is. They told us there's a pattern and it's geometric, so let's just double check. Okay, so if you put in 0 in the formula, what number will you get out? If you put in 0 in here, what number are you going to get out? 4. Very good. Okay. If you put in 1 in here, what number will you get out? 2. Okay, if you put 2 in here, 1. And then if you put in 3, hopefully you can do this. 1/2 to the 3rd is 1/8. So 4 over 8, 1/2. Okay, so what kind of ratio are we looking at? Multiply by 1/2. So this is a geometric series with r equals 1/2. Okay, so how many terms does this have? 21. Okay, so find the sum. We are going to use the geometric sum. Sum of 21 terms. Right, we talked about this. 20 minus 0 and then plus 1 because you always forget to add the original one. Equals to, okay, the formula says A1. Start with A1. Okay, trick question. What number is A1? 4. The first number is 4. The first number of my series is 4. I don't really care what A1 is. I don't care what A1 is. This A1 in the formula means first number of my series. First number of my series. Does that make sense? Okay, first number of my series. So 1 minus, and that was a 1/2 to the 21st over 1 minus 1/2. All right, this is a very, very complicated thing to solve on your calculator. Don't type everything in because the chance of you making a mistake is very high. I would do 1/2 to the 21st first, and then take 1 minus that. That's going to be a positive number. Multiply by 4, and then divide by negative 0.5. Yeah. Okay, first of all, when you try this on the calculator, because your number, this part, is a very small number, and then 1 minus a very small number is going to be very not accurate. So what happens is your calculator is rounding as you go, and so you get answers like 7.99999, something like that. It's actually 8. It's just that there was so much rounding that you couldn't figure out the actual answer, but it's 8. So on the test, if you put 7.99999, it's okay. But just know that if you have a multiple choice, it's actually 8, and then you want to choose the one that says 8. All right, next. Practice. All right, go ahead and do this one. Okay, so they already told us this is a geometric series, but you might want to just double check. It starts with the term 1, 1, 2, 3, 4, maybe. First number is going to be 5. Second number is -10. Third number is 20, and then -40. So you can see that R is -2. Now I'm going to tell you a trick. R is always this number. So if you didn't notice that yet, I just didn't want to tell you that because then you will always just look over there and instead of checking. And sometimes when things are not exactly right, you might pick the wrong thing. So just telling you like, the very, very basic way. And then now here's the shortcut. Okay, this is always R. Okay, so this is a sum of 10 numbers, 1 to 10. There are 10 numbers. First number is 5 times 1 minus -2 to the n, which is 10. Please make sure you put -2 in parentheses. And then 1 minus -2. So this is how you write it out. Please be careful. Okay, so -2 to the 10 is, I think, 1024. Yeah. Okay. Huh? No. 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers.
Oh, so you only add the extra one with 0?
No. 10 minus 1 is what?
9.
9 plus 1, 10.
Okay.
If you want to count it that way.
Okay.
Yeah. Okay, so this is going to be 1 plus 1024 over 3. And then, I think I did this wrong. Sorry, that's a minus there. Okay, so 1 minus 1024, 5 times -1023 over 3. Double check. -1705. Okay. Are you guys okay with the formula? People are nodding their head and some are just staring. So some who are staring, are you guys okay? Okay. All right. The last part is the confusing part. So let's make sure this part is okay before we go on to the next part. Okay. Last part. Converge or diverge. Okay. There are two kinds of series. One is called infinite. The other one is called finite. We talked about this before. So 1 plus 2 plus 3 plus 4, and 1 plus 2 plus 3 plus 4 plus ... How can you tell which one is finite and which one is infinite? It has a ... It's infinite. Just never ends. If it has a last number, that will be finite. Okay, so in an infinite series, meaning we're going to add up infinitely many numbers, we are going to figure out, does it converge or diverge? Okay, what does that mean? Okay, so first we had to figure out whether the sum converges or diverges. Converge or diverge. Converge means that if you add up all the numbers, eventually it becomes just one nice number or just one number. Diverge means that it just gets farther and farther away. It's just infinity or negative infinity. It never gets to a number. Okay, so, okay. Because we're talking about infinite series, n is going to be very large. So the sum, if it converges, it eventually arrives at a number when n is very large. Now, how do you know when it's going to converge or diverge? We can only sum up infinite series for geometric series. And then I'll show you why. How do you know if it converges or not? The absolute value of r has to be less than 1. If it does, then it converges. If it converges, you have an infinite series sum, and that is S equals A1 over 1 minus R. That's the last formula on your cheat sheet. It's the sum of infinite geometric series. So that's the last formula I'm going to quiz you on. This is the sum of infinite geometric series. All right, so let's take a look at this example. You just have to tell me if you think the sum is going to converge or is the sum going to diverge. Okay, 1 plus 1/2 plus 1/4 plus dot, dot, dot. What's the next number? 1/8, right? And then what's the next number after that? 1/16. You're basically multiplying by 2 in the denominator, right? Are the numbers getting bigger or smaller? Smaller, right? So eventually, if I add up all the numbers in this infinite series, is it going to sum up to a number, or it's going to diverge into like infinity? It's going to sum up to a number. So the first number is 1, and then it's 1/2, and then 1/4, and then 1/8, and then 1/16, and so on. You're adding a smaller and smaller number as you go along, right? Eventually, the number is going to become so small, it's like 0. So when you add up all the numbers, it's going to converge to just a number. Does that make sense? Okay, now what happens if it diverge? Diverge means that you're adding a bigger and bigger number. So, for example, you start with number, and then you add bigger and bigger, 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 bigger number. Eventually, what is the sum? Infinity, because you're adding larger and larger and larger number as you go. That's what we call diverge. Does that make sense? Okay, converge means that your numbers keep getting smaller. Diverge means your numbers keep getting bigger. Maybe we should just do it that way instead. Okay. Let's see. Okay, I just thought this poster was very funny. Nobody remembers this movie anymore? Yes. Yeah, anyways. I just think the whole series titles are very funny. Okay, so what happens if it diverges? Then absolute value of r, absolute value of r is greater than or equal to 1, then it's going to diverge. For example, 1 plus 2 plus 3 plus 4 plus dot, dot, dot. Is the numbers getting bigger, or are the numbers getting smaller? Bigger. So if you keep adding on and on and on and on, eventually you're going to add up to infinity, right? And then you add up all the numbers, it's infinity. The numbers don't really have any meaning because it doesn't come to a number. All right, so let's go ahead and practice. First, you're going to look at, let's see. Let's not do this one. This one is confusing. Let's try this one. So B, let's try this one. 2/3 to the n, and then n is equal to 1, and then goes to infinity. Infinity means that it's an infinite series. Okay, because it keeps adding until term infinity. So it just goes dot, dot, dot. Yeah, let's talk about that. First of all, I just want you to talk to your partner, A and B. which one converges, which one diverges? Which series is going to converge? Which series is going to diverge? Which series is going to converge? Which series is going to diverge? Remember, you're checking for R. R is the requirement. Is R less than 1 or is R greater than equal to 1? All right, number 1. Is it converging? Converging, raise your hand. Number 1, converging, raise your hand. Diverging, raise your hand. Yes, diverging. It is getting bigger and bigger as it goes. So that means R is greater than 1. Now, how do you figure out R? Take the next number. So 1/2 times R is going to get you 3/4. So R is equal to 3/4 over 1/2, which is going to be 3/2. So R is 3/2. You're multiplying by 3/2 every time. This number is bigger than 1, so it's going to diverge. All right, B. How many people think it's going to converge? Yeah, for B. How many people think it's going to converge? How many people think it's going to diverge? Okay, it is going to converge because R is 2/3, which is smaller than 1. Now, let's talk about how to solve this question. So, according to the formula, sum of an infinite series, this has no sum because it diverges. Okay, so if it diverges, just none. It's infinity anyways, so it doesn't matter. This one, because it converges, it's going to be A1, sorry. So just plug that into the formula. 2/3 to the first, sorry, let me finish this one and you guys are good. Why? Because it diverges. If it diverges, you're just adding a bigger and bigger number, right? And then eventually it's going to be so big, it's going to be infinity. Infinity is not a number we care about. It has to be an actual number, not infinity or negative infinity.